All right, so we are now recording. So everybody, please be careful of what you say and what you show on the video because it is all being recorded. Okay, so I just got through talking about the class. Now, the rules for how the class runs, those are in a disclosure statement. Now, if you guys were here live, I would hand you a piece of paper that has the disclosure statement. But since you're not here, what we're doing is we're doing it online. So I'm going to share my screen right now. Let's see, before I do that, I should open it up. Hang on a sec. Okay, so what I'm going to do is I'm going to open up Canvas. All right, so now I'm going to share my screen. Okay, so Aurora, can you see my Canvas screen on there now? Okay, so my Canvas screen is going to look a little bit different than yours. But if you go on Canvas, you should see something that looks like this, where you've got Albert Einstein trying to figure out E equals mc squared. Okay, so if you click on there, then it will take you to a page that's going to look very much like this. Now, again, because I'm a teacher, I have some options that you guys don't have. But this middle part here should be exactly the same as what you've got. Okay, and so down at the bottom, you see a couple buttons. So this button here will take you to where all of the assignments are posted, as well as quizzes and tests. This one here is going to take you to a bunch of class resources. This one takes you to the Zoom room, which you're already in. And this one just has a little bit of information about me. So let's click on resources and see what we've got here. So in the resources up at the top, you'll see there is a copy of the class, the syllabus. Now, some people call it a syllabus. Some people call it a disclosure statement. It's basically the same thing. So you can download it from there. And also there's another place, so I'll show you in a minute, where you can download it from as well. And that describes the class and how it's going to run. I have some other resources here that you might like. So here I've got some videos that if you go here, these are some pretty cool videos that I think you will definitely like. They're not required by any means, but I kind of think they're cool. You'll like them. If I go back here, you have some videos that I refer to as bovine excrement. That's a euphemism that I hope you guys understand what that is. There's a bunch of really stupid things. Like here's where, so Fox News is talking about the metric system and calling it the yoke of tyranny. Here's the thing about the Flat Earth Society, which we're going to talk a lot about. Global warming, is the coronavirus really real? There's a lot of astounding stupidity, especially on Fox. Fox Network they're the king of absolute stupidity. So I've got some really good links that I think are hilariously fun. So you're welcome to look at those if you want. And then I have a couple other links here. You're not going to need these now, but later in the year, we're going to be using the quadratic formula a lot. So this shows you how to program into your calculator and some other stuff, but we're not going to need that till later. Okay, so let's go back to the home page here. So for assignments and quizzes, let's click on that one. Okay, now I have a couple of things here that you don't see yet, like the flat earth assignment. That shows up on mine, but I haven't published it yet, so you're not going to see that yet. But as soon as I come over here and click publish it, you'll see that. But let's go up here. So homepage, resources. Here's another way to get into the syllabus. Now, your first assignment in this class is to download the syllabus and confirm that you've done that. So if you click on this, it'll take you to a page here, maybe. Okay, there it goes. Okay, and let me click on preview. That way it'll look a little bit more close to what you guys will actually see. Okay, so here yet again is another way to get the syllabus. So if you click on the syllabus, now if you click on the words, it will download it to your computer. But if you click on this other little icon here, it opens it up so you can view it without downloading it. Okay, so here's a list of, or here's a description of what's going on there. Let me just make that a little bit bigger just so easier for you guys to see. Okay, so this just talks about, contact information, description of what the class is. Some special information about how things are going to run during the online time here because of COVID. So your previous teachers have probably already told you all about this. So we're going to be meeting Monday through Thursday on Zoom here. Fridays are not going to be Zoom days. Fridays are going to be individual study days. But the weird thing is that the A-B schedule still continues. So like, for instance, this coming Friday is technically going to be an A day, but we're not going to meet. Then on Monday, it'll be a B day again. So you guys are going to have a Zoom class on Thursday, your B day classes. And then on Monday, you're going to have your B day classes yet again. So A day kind of got skipped there. So for us teachers, it's going to be a little hard to keep things straight, but we'll work it out. And you students, so you'll just take Fridays as an individual study day. That does not mean that it's a day off. You are expected to be working on Fridays. Okay, the grading policy in this class, 40% of your grade is going to be based on homework, in-class assignments, quizzes, and lab reports. 20% of your grade is going to be attendance and participation. Now, this is new for me because this is an honors class, and in an honors class, it's very rare that you give points for attending. That's very weird for an honors class. But Mr. Wilson has asked us to do it that way because he wants to ensure that you guys actually log on to Zoom every day. He's afraid that a lot of you won't. So you are required to log on. I am going to take roll, as you guys saw. I just took roll a few minutes ago. And by the way, the two students who just logged on a little bit late, you need to go into the chat box and you need to type here or hi or something like that. Because if you don't, you won't get marked for credit for today's attendance. And then 40% of your grade is going to be tests and special projects. Okay. And by special projects, I mean things like the rocket report. You guys may have heard about the infamous rocket report. It's a lot of work, I'll admit, but it's a lot of fun too. We're going to be launching rockets, I mean like real rockets, solid fuel rockets to go way up in the sky. And we got a little wind tunnel and all that kind of stuff. If coronavirus allows, we're going to be doing that. Now, the trouble is coronavirus may not allow. We'll have to see how that goes. Okay, so Sam is saying spooky. What is it the rocket lab that you're saying is spooky? Yeah, okay. Yeah, you guys will like it. The students really like it. It's a lot of work, I'll admit, but I give you lots of time to do it. Okay, the rest of the stuff you can read for yourself. I'm not going to go over. It's pretty straightforward. Oh, calculators. We should talk about calculators. Okay. I want everybody to have a graphing calculator. And what I mean by that is either a TI-83, TI-84, or TI-Inspire. Now, I realize that a lot of you guys have been using Desmos for a long time, and you've probably got a Desmos app on your smartphone, and Desmos can do everything that your graphing calculator can do. I agree with that. I mean, I love Desmos. I mean, the people who invented Desmos, I mean, they deserve a Nobel Prize. That is so cool. And so, yeah, technically, if you use Desmos, you don't really need a graphing calculator, but I still encourage you to get one, because when you get to college and you go to take a test in your math class or your physics class or whatever in college, they are not going to let you use Desmos on your smartphone because, you know, it's too easy to cheat. So they're going to want you to have a graphing calculator. So I recommend that you get one now, use it now, so that when you get to college, you're really familiar with it. Another question that people ask a lot about calculators is whether I like the TI-84 or the Inspire. I have a slightly different opinion than your math teachers do. I know the math teachers tend to like Inspires. I like the 84 or the 83. I like them a lot better. Now, I will admit the Inspires are quote unquote better calculators. Inspires can do things that the 84s can't, but that's both good and bad. I mean, I have seen a lot of students come into my class and they've got this fancy Inspire calculator and they don't know how to use it. The Inspire has so much stuff packed into it that it's really hard to sort through the menus and find the stuff to do the simple stuff that you need to do. So I think an 84 or an 83 is so easy to use. And it can do everything that most people will ever need to do. And if you're one of those few people that need to do something that the 84 can't do, Desmos can do it. So why bother with an Inspire? Now, Sam is asking the question. She says, aren't Inspires banned in universities? The answer to your question, Sam, is that there are two types of Inspires. There's the regular Inspire, and then there's one called a CAS, C-A-S. So it stands for Computer Algebra System. So the CAS version is banned, but the regular version is not. But anyway, so if you've got an Inspire, fine, okay? But if you haven't bought a calculator and you're wondering which one to buy, you know, I vote for the 84, whereas your math teacher is probably going to tell you an Inspire. I don't care. Okay, let's scroll on down. Okay, so what you see here, this is a schedule of what we're going to be learning and when. And this page is just boilerplate that Mr. Wilson asked us to put in our disclosure statements. I actually didn't write this. Mr. Wilson wrote this. So you've probably seen the same thing in your disclosure statements from other classes. Okay, now here's the important thing. The last page here. So if this was a normal year, I would hand you this on paper, and I would ask you to take the last page, sign it, and notice there's a space here where your parents need to sign it as well, okay? And then I would say, just return it to me. Now, if you want to do that, I will accept it that way. But this is not a normal year, so we have another way of doing it here. So if you scroll down on this page in Canvas, you'll see that I've got some spaces here where you can sign the disclosure using what we call an electronic signature. So basically, if you just, after you read the disclosure, then if you agree with this statement that you see right here, just type your name into the box down here, and that will be an electronic signature. I will accept that. Now, remember how I said that your parents are required to sign it too? So if you scroll down a little bit more, here's a space where your parents need to type their names. Now, some of you are going to be tempted to just type your parents' name in there. Do not do that. That is wrong, and in fact, it's illegal. If you come up to the instructions, you'll see in bold here, I've said students must not simply type their parent or guardian's name into the text box. Only the parent or guardian can do that. Typing the name into the text box constitutes a legally binding electronic signature, and it is a crime to forge someone else's signature. So when you get down here to this text box here, your parents need to be the ones that type their name in there. And by the way, tell them not to type their name unless they've actually read the disclosure statement, okay? And by the way, again, lots of by the ways here, you'll notice that there is some important text here that I will highlight real quick, okay? You see it says here that you will be using equipment that has the potential to be dangerous or even deadly if used improperly. So I have some cool stuff in my physics lab, which is also used for my robotics and my engineering labs. I've got a bunch of power equipment in there. I've got some saws and drills and drill presses and grinders and all sorts of stuff that if you guys were just walk into my lab and just pick up stuff and use it, you could very easily cut your fingers off, okay? So you've got to promise that you will not use any of the equipment in there unless I have signed you off and unless you've been trained properly in using it. So when you sign here, you're signing your agreement with all this stuff up here. Okay, so now there's one last section here. This is the section where I want you to type in if there's anything about you that I should know in order to help me do a better job of teaching you. Like maybe it's a little bit hard, maybe you're hard of hearing in one ear. And so if I were to sit you in this chair right here, your bad ear would be facing me. Whereas if I sit you over here, then I've got your good ear facing me. Or anything at all about you that I should know in order to help me do a better job of teaching you. I want you to write that in this box here, okay? And then when you're done, just submit that. So that is your first homework assignment, okay? So does anybody have any questions about that? We stop sharing here temporarily. Okay, so if you have a question and you want to ask it verbally, just hit the space bar and that will unmute you. Or if you prefer to type it into the chat box, that's okay too. Okay, so Miriam is asking, do you need a textbook? Okay, thank you for asking that, Miriam. That leads me into the next thing. Okay, so here is the textbook that you guys will be using. You don't need the textbook this week, but you will need it starting next week. Everything that we do this week will be done online. Now, even if this was a regular non-coronavirus year, I would still do it that way. I never use the textbook my first week in class. And there's two reasons why I do that. One reason is there's so many students that they think the textbook is the end all be all. And I don't want you to think that. The textbook is only one of many resources that we're going to be using in this class. But also the more important reason is I don't like to start the year doing boring textbook stuff. I want to start the year doing fun, hands-on physics. And so we will start today. You will do a physics lab today. Now you might say, how can you do a physics lab if you're at home? You'll find out, okay? But you will be doing a physics lab today. And so you've actually got two homeworks tonight. One is the disclosure statement, which you've already talked about. And the second one is you need to graph the data that you're going to get from your experiment today. You don't have to write up a report, just graph it. We'll talk more about that in a minute. But before I get into that, is there anybody else who wants to either speak a question or just type it? No. Can you do me a favor? Can you pull the door closed for me? Thank you. No, I don't see any questions, so okay. All right, so we're going to jump into the class here. Okay, so I'm going to start sharing my screen again. Okay. And when I do that, it loses the chat box. Let me get the chat box here. Okay, so let's go back into the home page for physics. Okay. And so let's go into our assignments page. So I'll click right here. And okay, so your first assignment we've already talked about. And the second assignment, which is also due next time we meet, is right here. So let's click on that. Let's see what that says. Okay, so this is our first physics lab. So if you scroll down on the page, you'll see there's a bunch of links down here that take you to some different simulated physics labs. Okay, so even though you're at home and you may not have the equipment that we have here, you can still do the lab. So every one of these is a lab that we would actually do if you were here. So like for instance, this one here, this is a Canon lab. So those of you whose last name starts with A, B, C, D, or E, this is the lab that you are going to do. So that would be Miriam, Zainab, and by the way, Zainab, if I'm pronouncing your name wrong, please correct me. Khaled, and again, correct me if I got that wrong. Will and Aurora. This is the lab that you guys are going to do. And I'll talk in a minute about it. And then down here, okay, if your last name starts with F, G, H, I, or J, you're going to do a lab that involves putting a mass on a spring, and then so forth and so on. So each one of you, you're all going to be doing different labs. But the question that you need to answer, or the questions, plural, that you need to answer, they will be the same for everybody. Even though you're doing different labs, you're going to be answering the same questions, okay? You're going to have what I call a two-part hypothesis that you need to add. You need to you need to talk about. So before I get into it too much, let's look at this word hypothesis, right? Hopefully this is not the first time you've seen that word. So can somebody please tell me, what is a hypothesis?
Educated guess.
Okay, so Jackson thinks it's an educated guess. Anybody else want to chime in? Or do you guys all agree that that does it? Okay. Okay, a prediction, I see some thumbs up. Okay, so a hypothesis is what you predict in advance is going to happen. Okay, so an educated guess. Now sometimes maybe it's not an educated guess. Sometimes it might just be a totally blind, uneducated guess, but you still have to have a hypothesis. Okay, so what you need to do is you need to make a prediction about what you think is going to happen. Okay, now before you do that, you're going to need to identify what is your independent variable and what is your dependent variable. So again, these are words that should not be new to you. So the best way to explain it is actually, let's pretend that we are one of the people whose names start in this range right here. So this is the lab that you're going to do. So let's click on it, and you see, so it's opening up this interactive simulation. And I'm just going to click on intro here. All right, so what have we got? We've got a cannon. And if we click on the cannon, we can drag it around so we can point it at different angles. We can even point it down if we want, okay? So what we're gonna do is we're gonna start here at 0, and we're gonna push this button, we're gonna shoot the cannon, okay? And then we're gonna raise the cannon up to about 10 degrees, and we're gonna shoot it again. And then we're gonna go to 20 and shoot it again, and 30 and shoot it again. So what is our independent variable in this experiment? Somebody speak up. What is our independent variable?
The angle?
Yeah, the angle of the cannon. That's the thing that we have control over. We can change that to be whatever we want it to be, okay? That's our independent variable. So the dependent variable is going to be how far does the cannonball go? And you see this tool right up here? Now, if you've got your video screen open, you might not be able to see where I'm pointing. So you might need to grab at the top of the video screen and drag it aside there. I've got this little thing that looks like a tape measure, and that is in fact what it's intended to be. So if I click on it and I drag it down here, and I put it down here at the bottom, and then I click on the end here, I can pull this tape out. And so I can measure how far the cannonball went. So in this case, it looks like if we shoot the cannon at 0 degrees, it goes for 20.79 meters, okay? So the distance is the dependent variable. The angle of the cannon is the independent variable. Does that make sense? Give me thumbs up if that makes sense. Okay, everybody good? All right, good. Okay, now, the hypothesis that everybody needs to make is once you've identified your independent, your dependent variables, the first part of your hypothesis needs to be, do you predict that there will be a direct relationship between your variables, or do you predict that there will be an inverse relationship? Now, again, I may be using terms that you don't know, but I'm hoping not. So somebody help me out here. If there is a direct relationship, what does that mean? If there's an inverse relationship, what does that mean?
Well, if it's direct, then when one goes up, the other goes up, and when one goes down, the other goes.
Okay, very good. If it's a direct relationship, then that means that as I increase the angle of the cannon, so as the angle gets bigger, the distance would have to get bigger if it was a direct relationship. Now, if it's an inverse relationship, then as I increase the angle, the distance would get smaller, okay? So what you guys need to do is you need to make a prediction whether you think is a direct relationship or an inverse relationship. Now, those of you who have had me in a class before, you know that I am a sneaky son of a gun, and it's entirely possible that the actual relationship might not be a simple direct or inverse relationship. There might be some really tricky relationship. And in fact, it's also possible there might be no relationship whatsoever. It might happen that if you change the angle of the cannon, the distance doesn't change at all. Okay, so you need to make a prediction. And in fact, I'm gonna have everybody make a prediction here. I want everybody to think about this. Do you think that there's gonna be a direct relationship or an indirect relationship? Or is it gonna be a trick question? Now, there's two parts to the hypothesis. The other part to the hypothesis is when you graph the data, so which is going to be your homework tonight, you're going to have to graph. So on the x-axis, you're going to put the angle of the cannon, and on the y-axis, you're going to put the distance. So when you graph it, do you think it's going to be a straight line, or do you think it's going to be non-linear? So let's do a little practice right now. Let's take a poll. I want everyone. Okay, so you should see a poll. It should have just appeared on your screen right now. So question number 1, and everybody needs to answer this, by the way. So do you think that it's going to be a direct relationship or an inverse relationship, or do you think it's going to be a trick question? And then the second question is, do you expect that it's going to be linear or nonlinear? So I'm going to stop talking. Everybody needs to answer. So as of right now, 7 of you have answered. There's still 10 of you who haven't yet. Yeah, don't worry, you won't be punished if your answers are wrong. Okay, so 15 of you have answered. There's still two of you still haven't answered yet.
I don't see the poll.
Everybody else is. How is it you're not
Weird.
seeing the poll? That's weird. I don't know why you're not seeing it. Okay, so I'll just stop it now. Okay, so 15 of you have answered, and here are the results. So 4 of you said that it's going to be a direct relationship. So what that means is you're saying that as the angle gets bigger, you're saying the distance will get bigger. 2 of you are saying it's going to be an inverse relationship. 2 of you are saying that as the angle gets bigger, the distance is going to get smaller. 9 of you think that it's going to be a tricky relationship, where it might be direct for the first little while, and then it's going to switch and start being inverse. Okay, and so as far as linear versus nonlinear, 1 of you thought that it was going to be linear, 9 of you thought it was going to be nonlinear. Okay, so I am not going to answer the question now of what's going to happen, because that's your job. If you are Miriam, Zainab, Khaled, Will, or Aurora, your job is to do this experiment and graph the data. And then when we meet again on Wednesday, I want you guys to share the results and tell us what is the real relationship between these variables. Okay. All right. So let's close that up now. And let's scroll down. So what if your name starts with F, G, H, I, or J? So this would be Calvin and Gia. You are going to be doing this lab right here. Okay, so this is the mass on a spring lab. So if I click on it again, I get the interactive simulations. Okay, now in this case, I don't want to take the first option, the one that says stretch. I don't want that one. I want to come over to this other option here, the one that says lab. So I click on it once and it gets bigger, and then I click a second time. Okay, so what we have here is we have a mass, and down here in the lower left, we have a bunch of masses. Please don't use the mystery masses. Use the mass that has the number on it. So I'm going to stick it on here and it automatically sticks. And so I put it up here and I let it go and it just goes boing, boing, boing. Okay. So it's going to oscillate like that. Now, what I want you guys to do is I want you to measure how much time does it take for the mass to go all the way down to the bottom and then back up again. Now, you could get out your stopwatch, or you could just use the stopwatch over here, over on the right side. And again, you won't be able to see this if you've got all of the video, the images here. So move the video image off. There's a little timer right here. So I'm going to click on the timer and I'm going to bring it in here. Okay. So what we can do is we can use this to time. And we're going to start the clock when the thing's up at the highest point, and we're going to stop the clock when it gets back to the highest point. So here goes start, stop. Okay, so it looks like the period, the amount of time to make one complete cycle, the period is 0.83 seconds. Now I'm going to do that again just for fun here. I'm going to try it a second time. Start, stop. This time I got a different number. What's the deal? Why didn't I get the same number? What's wrong here? Anybody got any suggestions? So Sam is thinking that maybe what I should do is take the average. Okay, I like that idea, Sam. So here's what I want you to do. Instead of just measuring one cycle, I'm going to measure 10 cycles. Okay, so already, okay, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now I take the time that I got and I divide that by 10. And so what I've done is I've averaged out 10 cycles. So I would report the period as being 0.817 seconds. So by using this trick here, I can get good reliable numbers even though it goes really fast like that. Okay, now, what is your independent variable? Okay, so let me stop it right here. Okay, you see this slider that I'm pointing to right here? When I move it over, notice how the mass gets smaller, and then as I move it over here, the mass gets bigger? Okay, so for you guys that are doing this lab, the amount of mass on the spring, that is your independent variable. So you're going to change the amount of mass, okay, and you're going to let it oscillate. You're going to measure the period, okay, and then you're going to increase the mass and do it again and increase it and do it again and just keep increasing it. So I want you to have at least 5 different mass settings. Actually, more is better. If you could do somewhere between 5 and 10 different mass settings, then that would be the best. Okay, so your independent variable is the amount of mass that's on the end of the spring. Your dependent variable is going to be the period, which is another way of saying the amount of time that it takes. Okay, so let's do a poll here again. Okay, so I want everybody in the class to make a hypothesis right now. So if your independent variable is the amount of mass, your dependent variable is what we call the period, okay? Do you expect there will be a direct relationship or an inverse relationship, or is this one of those tricky ones? And then when you do the experiment and graph the results, do you predict you'll get a straight line, or do you predict it'll be a curved line? So only 2 of you have entered. Okay, now we're up to 7, good. Keep going. Everybody needs to pick something here. So we're at 15, which is what we had last time. So apparently 2 of you must be having trouble with the poll function here, which is really odd. So who's having trouble with the poll? Who? Tell me your name.
Me, I'm Austin.
Okay. All right, so it's not working for Austin, and who's the other person? Oh, okay, the other person just took it. So Austin, you're the only one. I don't know why that would be weird.
Yeah, it's weird.
Okay. Okay, so let's end the poll and share the results. Okay, so 12 of you thought that it would be a direct relationship. 2 of you thought it was going to be inverse. 2 of you thought that it was going to be a tricky relationship. Okay. So 11 of you thought that it would be that when you graph the results, you're going to get a straight line. And 5 of you said that when you graph the results, it's going to be some nonlinear curve. All right. So again, I don't want to actually do the experiment myself. I want you to do it, provided that your name is either Calvin or Gia. All right. All right. So that's your homework for Calvin and Gia. Now let's let me close this out. Okay. Now, what about those of you whose last name starts with K, L, M, N, or P? So that would be Sam, Jackson, Austin, and Mia. All right, so this is the lab that you guys need to do. So you have a different lab, but again, the questions are the same for everybody. So now in this case, let's not do the intro. In this case, I want to come over here to where it says lab. So we're going to click on lab, and you'll see that what we have is we have a mass on a pendulum. So very similar to the mass on the spring, but not necessarily the same. Okay, so what we're going to do is we're going to measure the period. Now on this one, in order to get the little stopwatch, you have to come down to the lower left corner of the screen. You click on stopwatch, and so it pulls this up. Okay, so we're going to do the same thing. We're going to measure 10 times. So start. All right, so we're going to let this thing go 10 times, and then we're going to stop it, and then we're going to divide by 10. Now I haven't been keeping track here, so I'm going to pretend. Okay, let's pretend that was 10. Okay. All right, and so remember, whatever number you get here, you have to divide it by 10, because this number is not really the period. This number is actually 10 periods, right? Okay, so let me stop it here. All right, so like before, the amount of mass is going to change. That's going to be your independent variable. The amount of mass is going to be your independent variable. Your dependent variable is going to be the period. So very similar to the mass on a spring. Okay. Now you can see there are other things that we could change here. We could change the length of the string, but please don't do that. Whenever you're doing an experiment, you don't want to change lots of variables at the same time. You need to change one variable at a time. So we're going to hold everything the same except for the mass. That's all we're going to change. So our independent variable is the amount of mass. Our dependent variable is going to be the period. All right, so let's do another poll here. So I want everybody to tell me, what do you think? What's the relationship going to be between these two variables? Do you think it's going to be direct inverse, or is this going to be a trick question? Do you think it's going to be linear or nonlinear, or if it's a trick question, then let me know. Okay, so I've got 5 answers so far. Up to 10 now, 11. Keep going. I need everybody to type something in. Okay, so we're up to 16. Okay, so everybody except for Austin. All right, and so here are the results. Okay, so 9 of you expected it's going to be a direct relationship. So that means as the mass gets bigger, the thing is going to take more time. So in other words, it's going to move more slowly. Okay, that's what you thought. 4 of you thought that it's going to be the inverse of that. You're saying as the mass gets bigger, it takes less time. Okay. 2 of you thought that it's going to be some tricky relationship, and 1 of you thought that there's going to be no effect at all. Okay. And then down here, linear, nonlinear. Okay, again, I can see. So 11 thought it was linear, 4 thought nonlinear, and 1 thought it's going to be no relationship. Okay, so I'm not going to do the experiment. You guys are going to do it. And then, so on Wednesday, you guys are going to report back and tell us what did the actual relationship turn out to be. Okay, we're moving right along here. Okay, now, if your name starts with Q, R, S, T, or U, so that would be Dylan, Taituan, Cindy, Krista, Kyle, and Vian. This is the lab that you guys are going to do. Okay, so let's see what that looks like. Here's the link down here. Things opening up. Now this one, if we go with the default lab, it doesn't work right. So we've got this wrench here, and we jerk the wrench up and we see what happens. Jerk it down, see what happens. Maybe move it around a little bit. This one, if you do it this way, you're not going to be able to do the lab. So this is really important. If you're one of the people that are doing this lab, no, we need to click the box that says oscillate. So now we've got a little motorized thing that makes it go up and down. Okay, so this is what we want. Now over on the right side, we see that it's clamped here at the end, and that introduces some problems. I don't like that. So I want you to click on the thing that says no end. So you see what it did is it opened up a window, so the string has no end. Okay, and then there's one other thing that you need to set before we can do this lab. Down at the bottom, we've got this thing that says damping. So if we turn up the damping, you see the wave dies out really quickly. So I want to set the damping down to no damping at all. All right? Okay, so other controls that we have down here at the bottom, amplitude and frequency. Frequency is the one that I want to play with. Okay, so you can see, wow, my thing just did some weird, I don't know if you guys saw that. It just went a little bit crazy. It's back to normal now. Okay, so if you turn up the frequency, you can see that you get more wave crests there. Okay, so let's pause it. So the frequency is going to be your independent variable. Your dependent variable is going to be the wavelength. So if only there was a way to measure the wavelength. Oh, wait, what's this? I see a little thing down here that says ruler. So let's click on rulers. Okay, so here's a bunch of rulers that we can take and move around. So if we put the ruler so that 0 is right at this one wave crest right here, and we come over and we see the next wave crest is at about 2 so that would be 468. So about 2.3 something. Yeah, somewhere between 2.3 and 2.4. So let's just call it 2.3. Okay, so our wavelength is 2.3 centimeters. Okay, now here's one where I actually I'm going to show you the results. So if I turn the frequency down and then start it again, okay, that's a little bit lower than I'd like. How about right here? Okay, so now when I stop the thing, okay, you'll notice I've got a problem. The wavelength now is so incredibly long. How am I going to measure the wavelength? I can't see the other crest. Well, here's the solution to that problem. I'm going to take my ruler and I'm going to put it here so that the 0 corresponds with that first crest. And then I'm going to look to see where does it cross the dotted line here. So it crosses the dotted line at about 2.0 centimeters. Now, this is only 1/4 of the whole wave, okay? So here's the first fourth, here's the second fourth, here's the third fourth, and then the last one is over here. So this 2 centimeters that I've measured from here to here, that is 1/4 of a wave. So then what is the wavelength? Well, the wavelength is 4 times that. So the wavelength then apparently is 8.0 centimeters. All right. So everybody understand your independent variable is the frequency, your dependent variable is the wavelength. Now, because I just did a couple of runs here, everybody should get this next question right. So let's take a poll here. I expect everybody should be able to tell me whether this is a direct relationship or an inverse relationship. Okay. Now the linear, nonlinear part, okay, that one's hard to tell. But the direct versus inverse, I'm expecting that everybody should get this one right. Okay, so you should see the questions. Okay, good. I see people are starting to take it. Okay, so I've got 4 answers right now. I'm up to 6. Okay, up to 9. I still need more people to take it. Everybody has to answer here. Okay, we're up to 13. Okay, sorry. Everybody except for Austin has now answered. Okay, let's see what you guys said. Ooh, this is interesting. 11 of you said it's an inverse relationship. 5 of you said that it's a direct relationship. So this worries me a little bit. Okay, those of you that said that it's a direct relationship, you need to think about this a little bit more. Direct relationship means as the independent variable gets bigger, the dependent variable gets bigger too. So let's see what it looks like. So here we've got a really small, our independent variable now is really small. So you'll notice our wavelength is really, really long, okay? So when the independent variable is small, the dependent variable is really big. So as we increase our independent variable, now you see the wavelength is now getting shorter. So you guys should realize that's not a direct relationship, that's an inverse relationship. So the 5 of you who said that it was a direct relationship, go back and rethink that. Okay, and then the linear versus nonlinear, that one, we really can't, or at least most of you may not be able to make an educated guess on that one. So, okay, make an uneducated guess. That's okay too. You got to have a hypothesis. So 9 of you thought it was going to be a linear relationship. 7 of you thought it was going to be nonlinear. And so if you are in this group, so this is Dylan, Taituan, Cindy, Crystal, Kyle, and Vian. Okay, so your job is to do the experiment, graph it out, and then on Wednesday, I want you to meet back and tell us what the answer turns out to be. Okay? All right. Oops, that wasn't what I wanted to do. Sorry, let me come back here, redo this again. Okay. So, all right, so I just closed it. Okay, so now let's do the very last group here. Close that out. Okay, so if your name starts with V, W, X, Y, or Z, which in this case is only one person, this is Connor. So Connor's the only person in this group. That's not good. Tell you what, Kyle and Vian, can you please switch? Instead of doing the lab that I told you to do before, I'd like you to do this lab here. I don't want Connor to be all by himself. So Kyle, Vian, and Connor, this is the lab that I want you guys to do. All right, so let's click on the link here. It takes us into the intro. And okay, so what we have is a laser, and it's up in the air. And down here, the blue here, you see that's water. So when I shine the laser and it hits the water surface, some of the light gets reflected and some of the light gets transmitted. All right. So as I change the angle, you'll see something very interesting. So the reflected angle is always the same as the incident angle. But this angle over here, the one that gets transmitted through the water, you'll see it does get bent. I mean, you can see it clearly does get bent. So we have a word for that. We call that refraction. And so that's what we're going to be interested in. So down in the lower left, you can see I've got this little protractor. So I'm going to pull this protractor in, and I'm going to position the protractor right there. Okay. So if those of you that are doing this experiment, your independent variable is the angle of the incoming light. We call that the incident angle. And notice that we're measuring it from the vertical downward. So this is 0 degrees. This is 10, this is 20, this is 30, okay? And then your dependent variable is going to be the refracted angle, which is down here. Now you guys can already see what's happening here. As the incoming angle gets bigger, you can see what's happening to the refracted angle. So the direct versus inverse part of this, you should already now know the answer, okay? But the linear and nonlinear part, that one's not so easy. All right, so let's see what happens here. Everybody, I want you to make a two-part hypothesis. Let's see what you guys think. Now, the direct inverse part here, I expect everybody should get this one right. But the linear and nonlinear part, well, hard to say. Okay, so we got 7 of you who have answered. Up to 10, 11. Come on, everybody has to answer here. 12. Okay, 4 of you haven't answered yet. Okay, now we're down to 2. 2 of you haven't answered yet. Okay, one more person. Need to see your answer here. And when I say one person, I don't mean Austin. Okay, looks like maybe we lost one student here.
No,
okay.
It just says it failed to submit the poll.
Oh,
Says,
that's
like,
weird.
Error 1060 or something.
Huh. Okay, all right. Well, okay, so I'll just go ahead and end the poll then, and here are the results. Okay, so 4 of you thought that it was inverse. I'm really concerned about that. This one should have been pretty clear. I mean, look at it right here. So here the angle is small. So the incoming angle, our independent variable, is small. Look at our dependent variable. It's also small. As the independent variable gets bigger, so does the dependent variable. See? Okay, so the bigger the independent variable gets, the bigger the dependent variable gets. So everybody should have been able to recognize this was an inverse, or this is not an inverse relationship. This is a direct relationship. Okay, now the linear nonlinear part, that one's hard to tell. So the only way to know that is we'll have to do the experiment. So Kyle, Vian, and Connor, your job is to do the experiment, graph the results, and then next time we meet, I want you to report back to what the results are. Okay? All right, so are there any questions from anybody about that? Okay, so I see down here in the comments, a couple of people have typed in something here. So Sam is saying it would have been inverse if you were looking at the reflected portion to the right. No, even then, it still would not have been. I mean, let's look at the reflected portion, okay? So the incoming angle is small, the reflected angle is small. The incoming angle is bigger, the reflected angle is bigger. So it's still a direct relationship even then, okay? Let's see, what else do people say here? Okay. Oh, okay, so Will is asking about the graph. Okay, so that's the next thing I need to talk about here. So let me go back and share my screen again. Okay. All right, so if we go back to the Canvas page where the assignment is described, up here at the top, it says, okay, I've just highlighted it here. Okay, so you don't have to do a written lab report. Okay, all you have to do is graph the results and upload a photograph of your graph. And so this is the important part right here. Okay. So I realize that many, if not most, if not all of you, should know how to use Desmos to graph things. And you're probably going to want to use Desmos. I don't blame you. So would I. I love Desmos. Okay, but for this assignment and this assignment only, I want you to prove to me that you know how to graph things by hand. Because one thing that I've learned over the years is it's astounding how many people don't really know how to graph things by hand and how to adjust the axes and figure out to make it so that the graph kind of fills the whole page. All right, so for this assignment only, everybody needs to graph it by hand. Now, some of you might say, but Mr. Hendricks, I don't have any graph paper. Well, hey, I've thought of that, okay? So this link right here, if you click on that link, it will download graph paper. Now, if you just click over here, it shows you the graph paper, but it doesn't let you download it. So you need to download it, okay? So click on the words graph paper, and it will download. You see in the lower left corner, okay, it'll actually download the graph paper so you can print it out and graph it by hand. So the independent variable is the X, goes on the horizontal axis. The dependent variable is the Y that goes on the vertical axis. Okay, so I want you to graph it. And by the way, before you take a photograph, I want you to write on the paper. I want you to say, my hypothesis was, and then tell me what it was. And don't worry if your hypothesis turns out to be wrong. I'm not going to dock you any points for that. It's okay if your hypothesis is wrong. That happens a lot in science. But it's not okay to not have a hypothesis. So be honest. Make a hypothesis before you do the experiment. And then do the experiment. And so then write your hypothesis and your graph. Then take a photograph of it. And then upload the photograph. Now, where do you upload it? Well, here on Canvas. Now, because I'm in the teacher version right now, I don't have a button. But if you were on the student version, up at the top here, there'd be a little button that says submit. Okay, so when you submit this, you just send me the photograph that way. Okay, so let me ask again, are there any questions from anybody? Okay. So my chat screen, oh, there's my chat screen.
I
Okay,
have a
so,
question.
okay, hang on a sec. So Calvin is saying that you don't have a printer. That's going to be a problem. Well, Calvin, can you get some graph paper somewhere from somehow? I have graph paper here at school. So if you want to come in at school, I can give you some graph paper. Okay, so who had the question? Was that Jackson?
I don't have graph paper either. I can't come to school. However, can I just draw the graph on like plain paper?
Well, but if you draw it by hand, then it's hard, then you can't say whether it's linear or nonlinear. So,
How so?
well, in order to be able to say with confidence whether it's linear or nonlinear, you got to make sure that all of your data points are spaced out exactly right, both horizontally and vertically. If you just do a freehand sketch, maybe your spacing's not right.
I could use a ruler if you'd like.
Yeah, you could. Or tell you what, Jackson, I'll make a special exception for you. If you want to do it on Desmos, I'll let you get away with it.
Okay, cool.
And by the way, for the rest of you, after we do this one assignment here, the rest of the graphs we do, they're all going to be done on Desmos because Desmos is so much better.
Okay, I have one other question.
Yeah.
So would we be doing this individually or with a group of people with our same last names?
Everybody has to do this individually. Now, if you want to collaborate with the other members in your group, if you want to call them up and say, hey, this is what I got, what did you get? I'm all in favor of that. By all means, yeah, that'd be great. But everybody has to submit their own graph.
Cool.
Okay,
Thank you.
are there any other questions? All right. All right, so Caden, I noticed you just joined the class. So you probably didn't understand what we just talked about because you missed the first half of it. So Caden, if you were to stick around a little bit longer after everybody else signs off, I can tell you basically what we want to do. But before we sign off, I want to take roll a second time. I know we've already taken roll, but I'm going to be doing this, and I think the other teachers are going to be doing it too. I want to take roll again, just to ensure that you guys didn't, leave in the middle of the session here. So I want you to do the same thing you did last time. I want you to type something in. I see some of you are typing in by, so that would be good. You can type in by, or you can type, if you want to type in a joke, whatever. I'm okay with that. And so once you do that, then it's okay to sign off. I will see you next Wednesday. Remember the homework, we got 2 homework assignments. They're both due at the beginning of class next Wednesday. So Sam, of course, typed in the word joke. Hey, Sam, it's good to see that your sense of humor is still there. And Aurora typed in rawr. So good for you, Aurora. I like that. Okay, so the rest of you, except for Caden. Caden, I want you to stick around, but the rest of you, goodbye. All right, so Caden, I'm not seeing you on video here. Are you still here with me, Caden? Nope. Okay, Caden, I'm not seeing you. All right. Okay, well, in that case, I'm going to turn off the recording, which I should have done anyway.